So this is the next part, and now we will be discussing about Ramsey interferometry structure. So this is mostly known as golden diagram, which we'll be using mostly in quantum computing and quantum physics as well, quantum mechanics as well. But this is not a very big jargon, and this is not very difficult to understand as well. Right now we will be discussing this as simple diagrams, and then we will discuss this as something called inside diagrams, and then after this we will go into matrices, like real matrices, and multiply them based on their values. So what we have here is, like, let's consider that this is an electron, and most importantly this is like the conversion of probability amplitudes into different outputs, and this is like another part of interference. This is mostly interference discussed in different shapes and different diagrams. So what we have here is an electron, and consider that this electron is in like excited state, so ground state, whatever, and we put that electron into a resonance interaction box, and what it will do is that it will convert its shift from ground state to excited, or excited to ground. This is what this box do. And then another box is phase shift. This is the most important one, because this is where we have a change in the angles of our velocity or our values in interference. And then we have another resonance interaction box, which will like end up the probabilities. So in short terms, what we have here is like an electron. We put that into a resonance interaction box. What this box do is that this opens gateway for quantum interference. Like, it opens the interference, and we have two probabilities at the time, and then the phase shift happens, and after that this box closes the interference. Like, we have two interference, and like this here, they get closed, they get opened, have some phase shift, and then they get closed. That's it. Okay, so the values here, like in this box, let's talk about this part. The values here are not that important right now, because we will be discussing them into matrix part and gates part, where we have Hadamard gate and X gate, OR gate, and XOR gate. This is not the part we have to discuss right now. So let's discuss what is going on here. Okay, let me get this clean. So I like clean things. Okay, so we have two states here, excited state and ground state. First we have the electron or any particle in ground state. We put that into this box, and then it do a phase shift. It do like shift, and it's converted into excited state. And how it is gone through, the fact is this is 1 over square root of 2. So to go through the excitation, it goes through this part, 1 over square root of 2, and then this goes into the phase shift box, and it gets some phase shift by alpha 2, a different value than alpha 1, and it goes along. And what we have here is another resonance interaction, which is minus 1 over square root of 2, and then which is used to close the interference here, and then it is and then we get the output in excited state. So this is the one part, and another part is that we have another way of going through this part, and that is phase shift alpha 1 or phi 1. How we go through this is that we have the electron in ground state, and we went through this, and we experience this resonance interaction, 1 over square root of 2, and then we move on along, and we have a phase shift of phi 1, and then we move on, and then we have this resonance interaction of 1 over square root of 2. Okay, and then we have another excited state. So what is this telling is that we have a starting point and we have an ending point. A starting point and an ending event, both are same, but we have two different ways of approaching that ending point. And this is what interference is. Interference is, we have two different paths going on to the same event, and which one is better, which one is actually computing, which one is actually making it go there, is based on their phase shift. Other than that, these values won't matter. They are mostly same, and they are only used to like make you understand the matrices which will be like discussed in the other part. And let me do some maths here. Like what we have here in the, like in probability amplitude is that we have, I think I should remove this part so you can actually see more stuff. I'm actually really enjoying recording this lecture because this is really fascinating. These like core concepts are really boring, and you don't get the intuition behind the bigger parts, like the bigger intuitions, the bigger ideas which scientists came along in like a long time ago. So they might be a bit boring. You only get to see a lot of maths, but in main general results we have different ideas which are really fascinating. Not they are actually maths, but to understand them you have to understand maths. But in general terms they are really fascinating. So what we have here is like we have probability amplitudes alpha. So let me confirm that I am doing correct. Yes, it says it is. Okay. So let's do this from start. We have a ground state and we went through this. This is I think I should write it a little bit bigger so you can see it. We go through this part, like the interference box, and then you go through the phase shift alpha 2. And you know that you don't write like this in like simply alpha 2. You have to write this in the power of e in the complex number form, with Euler number e iota alpha 2. So this is what happens when it goes through this part, and then it goes from like closing the interference part, which is -1 over square root 2, -1 over square root of 2. So this is one part. So when in last video I discussed that if you have two events going along to the same event, you actually add them and then take the squares. So this is the first part, and then we have another part when it goes through this part, like this phase shift phi 1. I'm actually calling it alpha 1 again and again because they are actually like probability amplitudes, not phase shifts. So these are phase shifts and these are probability amplitudes. So we have another one here, this is 1 over square root of 2. And then again we go through this phase shift which is alpha 1. So now we will write ei alpha 1. E iota, sorry. This is not I. Yes, I'm right. Okay, so now we have another part which is like positive 1 over square root 2. So we will actually write this again as it is. So I'm going to remove this diagram because we have actually seen it how it goes down to excited state, start to an event, but we have two paths defining two phase shifts. Okay, so I'm going to remove this part. So you can do a lot of maths. So I actually not love doing maths in equation form, but I love understanding the maths. So I will try to make you understand rather than focusing on the equations, but I will do it in the basic way as well, so you can actually get the intuition or idea that how this is actually working. Like why we have this here, why we have this here, and why we have this here. They are very important. But for now, you have to actually focus on that these are probability amplitudes going from event to event and doing this math. And then when we will write this in matrix form, we will actually get the idea why we are using this and this and this. So now what we will do is that we will take the square. Like we have probability amplitude, like a wave amplitude, and we will convert this probability amplitude into probability. So what we do is we take squares. So we take square here. Yes, we take square. So I will not do the complete maths here again, and I have shown in the previous video where I actually compute the whole equation of maths. Not actually sometimes I have to use the calculator here. It's not that difficult, but I will go straight with the written equation. So if you take square here and take square here, it will actually convert into 1 over 4 plus 1 over 4. you can actually see this is how this actually comes apart. So take square here and take square here, where square root is like empty and you have 1/4 and 1/4, and after that you have this minus 1/4 to cos. We have ei alpha 2, ei alpha 1. What we do here is we take the basis and add the powers, and we will get is phi 1 plus phi 2. I think that's correct. Oh, okay. So we have negative here, and the reason is that we have this part here. That's why we put the negative part here, and then we have 2 cos phi 1 and phi 1 minus phi 2, and then we convert this into simple form. What we get here is 1/2 minus 1/2 cos alpha 1 minus alpha 2, and then we have alpha 1 minus alpha 2 to convert this into to have this in simple phase shift form. We are going to make this in alpha 1 minus alpha 2 form. So what we have here is phase 1 minus phase 2 form. So what we have here is simple phase, and this is going to be converted into 1/2 minus 1/2 cos phase. So another intuition here is that you have heard about the cos to sine converter formula, which actually converts into sine square phi by 2. We have, which is I think I'm not sure about this, so let's go directly. And this is 1/2 and 1/2. That's why we have phase multiplied by the value we have in common here with sine square. So we have sine square phase over 2. I think that's it, and the whole value here is controlled by this phase. And I actually defined or explained in the before that we have this starting point and this part to go to this event, and you have this part to go to this event. Okay, so you have 2 events. You have 1 event, 2 ways, and 1 starting point, and both events are controlled by phase shift alpha 1. Oh, sorry, I'm mixing it again. Phase 1 and phase 2. Sorry, phase 2 and phase 1, whatever you want to say them. Both events are controlled by this phase shift. Okay, so this phase shift is here because their difference matters a lot. So based on their difference, we actually get to know the value of the sine, and the value of sine is actually going to show you the position of qubit, which is another concept. The position of qubit in a Bloch sphere, on a Bloch sphere in Hilbert space. So that's why we have sine here, because sine is actually going to tell you how much above is the point, how much above the point is from x-axis or y-axis. That's why we have sine or cos to tell you the value in Cartesian plane, or in 3 dimensions you have Hilbert space. So that's why these values are important, and that's why we are using this and this, because we want to compute the angle and the value in Bloch sphere. And they are actually defined by complex number, because we don't have a single value here in the Bloch sphere or Hilbert space. And that's why, and E and I cannot be like defined on a sphere or space in easy terms. That's why we use the Euler's formula to convert them into cos and sine, so you can actually see them in a 3-dimensional space or in Bloch sphere. That's it. I think I have explained the idea behind Ramsey interference and interferometry design, which is like which was defining interference but in like easy way. So you can see the diagrams which are designed before. You have 1 starting point, 1 event, 2 probabilities, and they are defined by phase shift. And this is the maths behind it. you go through this, you go through the phase shift, you go through this, and you go through another phase shift. You add both of the events, you take the square, and you do the math, and you get here. And the value here is controlled by phase. Okay, so if you have higher difference, you have another probability. You have lower difference, you have other probability based on how you are taking the main probability and how you are taking the secondary probability based on the event. And event is actually happening because of the difference between these two. That's it. And this was the second part of the lecture 1, and I will try to go more easier. I think it was easier because no one is going to do this, all of this fast, because I'm seeing many videos, they actually don't do this. And to get idea, I actually used ChatGPT to get to know how this math is actually working behind. And it was really helpful for me. So I thought that why don't I record them? So I don't have to go to ChatGPT's history and see again and again where I ask him. So I can actually go and see my videos and get the idea. That was the part where I was stuck. So that's it. I will see you in the next one. Good luck. Allah Hafiz.